My name's Mollica, and welcome to my demonstration. This first image that you just saw was created using a sky dome, with a 360 photo set as the background. Getting the right angle created the illusion that the Wii remote is sitting on the sofa. Heading into Maya, you can see the objects that make up my model. Here's a quick look around everything. Every object in my model uses real Arnold materials, using AI standard surface. For the batteries, I used the gold preset and changed the color. For the plastics, I used the plastic preset. With the A button, I changed the blending to 30% to make it more translucent. Around my model and background, I have an Arnold sunlight dome that simulates physically accurate sunlight. Now I'm going to assemble the model to show you what it looks like all together. Notice how the batteries perfectly slot into their locations. The following section will show you the untextured model, along with a series of high-quality renderings using Arnold. Now we move on to the second deliverable, where I will animate the model in Unreal Engine 4. Here is a quick look around my imported, textured and fully lit model. This model was imported object by object as .fbx files that were then assembled to create this final model. Here's a quick look at the sequencer that I used to make the animation. On the left you can see all of the imported actors, including cameras, and the red dots represent the keyframes. Here's a slow walkthrough of the animation frame by frame, using the two cameras, time dilation and ambient fog. Notice how the animation makes use of concepts learnt in class. Looking closely at each object, you can see that it's been imported perfectly and textured accordingly, like the Maya counterpart. All the materials were also imported in the .fbx files with the objects. Each material had to be edited a little bit to get them exactly right, as there were some issues when crossing between Maya and Unreal. My imported models are also shown along the bottom. Here is my finished, rendered animation. Now onto deliverable 3, the interactive component visualizer created using OpenGL. This is what my completed model looks like once it was implemented. Using the left and right arrow keys, the model can be rotated. Pressing the down arrow disassembles it, and then the up arrow reassembles the model. Using the built-in FPS camera, I can fly around the scene. Notice the individual objects each reacting differently to the light. Here's a quick close-up of the battery and screw textures. As for the code, these meshes and textures are where I defined new instances so I could import each individual object. This code here defines my variables used for the FPS camera, and also all my light variables, such as specular and diffuse. These few lines set my application to full screen. Each individual object is imported as a .obj file and loaded using the model loader, and then their textures are wrapped. This following line imports a texture file. This one is a .jpeg. The next few lines create a program and attach the shader files to the program. The initial object loading, binding textures, texture wrapping, and importing of texture files is done for every single object. However, new shader files do not need to be defined and created, as I am attaching every single texture and object to the same program. This small line here defines the model rotation using a vector 3. This makes the model start from the center. Here's a quick look at my fragment shader. The fragment shader handles all of the lighting and texturing. This section at the bottom multiplies by the texture so that the texture and the lighting can work on the object together. And here's a brief glance at my vertex shader. This handles the texture coordinates and the positioning of the actual texture on the model. This section of highlighted code is how my interactive animation functions. It uses a model position array that has all of the positions of each individual object in it. Using key callbacks, it checks whether the up or down key is pressed and adjusts the model position coordinates accordingly. This model array can be seen here. This piece of code defines the callbacks for use of the first-person camera. The code above it defines the callbacks for moving the light around the scene. The lighting position and all of the lighting variables are actually used here and attached to the program so they can be used in the scene. This small snippet sets the axis of texture and binds it to the object below. Here you can see my model position actually being used in the translation of the object and indexed into the correct position. As you can see, each object has a different index of the model position corresponding to what was previously defined. The models are then rendered using the .draw function. Each model is rendered individually, and based on the position, it renders in the assembled layout. Here's a quick glance of the code that senses the position of the mouse that is used in the first-person camera. Also, note this if statement in the animation code. This prevents the model from overlapping itself when it's being rebuilt. Thank you very much for watching my demonstration, and I hope you enjoyed my product.